In Learning Outcome 3, we learned about collecting data through primary methods like interviews, observations, questionnaires, and experiments. We then actually created a data collection tool on Applied Activity 3. On Applied Activity 4, we learned about variables and scales. And on Applied Activity 4, you actually had to classify the data that you had collected. The next step, once you have your data organized, is to analyze the data to obtain answers to your research questions. However, before you can actually perform the analysis, you need to make sure that your data is accurate, complete, and suitable to answer your research question. To do this, you can follow 3 main steps: coding and entry, editing, and transformation. In this video, we're going to talk about coding and entry of your data. The first step in data preparation is a process that is called coding. Imagine that you get respondents to answer a questionnaire with paper and pencil, or you're taking notes during an interview by actually writing them down on a piece of paper, or you're observing people, like in that video we watched of people on the busy street, or even coming in and out of a cafe, and you're writing those notes down. In any of these cases, the notes need to be transferred into a computer. That is what is called data entry. To speed up the process, usually a coding scheme is used. A coding scheme needs to assign a number to a response so it can be easily entered. For example, instead of using the words yes and no, usually it can be faster to just simplify and use what's called a code, calling a yes a 1 and a no 0. This will simplify the process and it should help to reduce errors. So for example, for dichotomous responses like yes, no, we usually use 0 or 1. Or for a scale like very dissatisfied all the way to very satisfied, people would usually use like a 5-point scale. Did you say 1, 2, 3, 4, or 5? Those numbers would represent the words like very satisfied, satisfied, not applicable or in the middle, neutral, dissatisfied or very dissatisfied, instead of having to type out that full word. Sometimes when there is no response to a question, people use a 9 or 99 or just leave a blank to represent that people did not answer the questions. The problem is that human errors can be very common when coding. Even if you're shortening the words used by using numbers like 0 and 1 instead of yes and no, you could still hit a wrong key. This is why electronic questionnaires are preferred, because they eliminate the need for manual data entry. Things like Microsoft Forms or Google Forms can automatically record what people's answers are, so you're ready for analysis without having to type answers in. Here's an example of what I was describing. When we have our Smoke-Free Campus questionnaire, we ask people a series of questions, and if they strongly agree to strongly disagree. We could make a coding scheme where we call a strongly agree a 1 all the way up to a strongly disagree a 5. You can see that this coding key is necessary because you need to know, are we calling a strongly agree 1 or are we calling a strongly agree 5? You can order it in either direction, and the direction does not matter as long as you are consistent. So instead of typing in that they strongly agree with question 1, I just put in the number 1. Instead of saying they were neutral for number 2, I'd code it as a 3. Instead of saying they disagreed with the third question, I put that as a 4. And that is your coded entry and how you start entering information with a coding scheme. Another example, once you actually have coded your data, how do you present it? Some possible results from the Smoke-Free Campus survey are people can answer yes, 0, strongly agree, disagree, 2, no, woman, I have never tried smoking a cigarette. But the problem is, if we don't know what questions these answer, you can't draw any meaningful conclusions to the data. Is no the answer to are you a smoker or not? Or is no the answer to do you think Cambridge should have a smoke-free campus policy? We just do not know unless we organize our data. So once you have this raw data obtained, how do we organize it? In research, we always use what's called a data table. In a data table, it's just an arrangement of your data where every single row would represent a person. So if I start with their ID, this would be person number 1, person number 2. For confidentiality, we aren't putting their names, just a number for each person. Then, once we know who the information is for, So the ID variable in column 1 tells you who. We can get the context of what the information is about by making headers for each of the columns that tell you what information is recorded. So the ID gives you who, the various columns tell you what. So that yes and no are the answer to are you a smoker. The 0 or 2 or any number was an answer to like the number of cigarettes. When you first tried tobacco, we can also put that as a number, like 0 is never, 1 is 10 years or younger, 2 is 11 to 13, 3 is 14 to 16, 4 is 17 to 20, 5 is 21 years or older, so that you don't have to type in those whole words or ranges every single time. And this is how you would use coding and data entry at the same time to create this data table, where every single one of these rows represents a different person, and the columns tell you what question is being answered. Once you know what question is being answered, we call that your context for your data. If I look at all the results from my electronic questionnaire in Microsoft Forms, it would give me all of the answers, so every single person that answered, the full question text, and what their response is. This information is automatically available to download in Microsoft Forms. Please watch the video at the bottom of this lesson to see how you can extract this information from Microsoft Forms.